All right, guys, in this video, we're going to talk about how to determine the average velocity or average acceleration of an object moving along a line. So if v of t is the velocity, then average velocity is you just take the definite integral of the velocity and multiply by 1 over the width of the interval. So for this case here, you have the definite integral and 1 divided by the width of the interval. To get average acceleration, you do the same thing, but you're using the acceleration function there. So a couple things to note that can sometimes be a little confusing with velocity, acceleration, speed, and those kind of things is suppose you have an object and its position is given by the function x of t. Okay, so it's implied that it's moving along a horizontal line. If the derivative dx dt is equal to the velocity function, not if, but it is. So if this is greater than 0, then that means that the object is moving to the right. And if dx dt, which is the velocity again, is less than 0, it's moving to the left. Now, if this was vertical movement, it'd be moving up if the velocity is positive and negative if the velocity is negative. And remember the connection here, velocity is the derivative of position. Similarly, dv dt, or the derivative of velocity, is the acceleration function. So if the acceleration is greater than 0, okay, then the object um, the object's acceleration, or excuse me, the velocity is increasing. And then if the acceleration is negative, then the velocity is decreasing. Now, oftentimes a question will ask, is the speed of the object increasing or decreasing? So here's a quick way to figure that out. If velocity and acceleration have the same sign, in other words, they're both positive or they're both negative, then the speed is going to be increasing. If the velocity and acceleration have opposite signs, in other words, one's positive, the other's negative, or one's negative, the other's positive, then the speed of the object is going to be decreasing. There's often a question like that going to be asked of you. So we want to find the average velocity and average acceleration of an object on a line. So we have this function v of t equals t plus sine t for 0 to 10. What's the average velocity? So the average velocity for this one is going to be 1 over 10 minus 0 times the integral from 0 to 10 of v of t dt. So this is 1/10 integral from 0 to 10 of t plus sine t dt. So this would be 1/10 times 1/2 t squared negative cosine t from 0 to 10. And then you would plug in 10 and 0 and subtract, and you'd get approximately 5.184. And the units on the velocity are centimeters per second. So centimeters per second there. So to find the average acceleration, so for part B here, we need to get the acceleration function, which is the derivative of velocity, which is going to be 1 plus cosine t. So the average is 1 over 10 minus 0 times the integral from 0 to 10 of 1 plus cosine t dt. Now, in this case, we differentiated the velocity function to get the acceleration. And now to get average acceleration, we're going to anti-differentiate. So we should get back to the function for velocity here, so which is t plus sine t from 0 to 10. If you plug both of those in and subtract, you'd get 0.946, and the units would be centimeters per second squared. Okay, so I want to take a quick second and show you how to do those on Desmos. Okay, so we have our velocity function here, t sine t. To get the average velocity, do 1 over 10 minus 0 times int from 0 to 10. Now you could have put 1/10 there, you didn't need the minus 0, but I'm just being consistent with the notation here. And then v of t dt, and you get 5.1839 or 5.184. Okay, now again, on the AP exam, it's enough to write the notation that we have right here and then go straight to the answer if you're allowed to use the calculator. And similar thing with the second question as well. So another cool thing we can do to get average acceleration, again, 1 over 10 int 0 to 10. Now remember, the average acceleration is the 1 over b minus a, or t1, t2 minus t1, times the integral of acceleration. You can actually type in v prime of t because that is the acceleration function. If you wanted to, you could differentiate 0 to 10 and then put in 1 plus cosine t dt, and you get the same thing. All right, so pretty cool stuff there. All right, guys, that's it for this one. Hope that was helpful to you. Reach out if you have questions, and take care.